Afe Ademola Johnson. Now we want to continue from the series of SS1 topics in chemistry. Today we are looking at ions. But please don't forget that if this thing I'm doing to you is beneficial to you, please be beneficial to me too by clicking the subscribe button, the notification button in YouTube, and endeavor to follow in Facebook and comment. Make comment, and God will bless you in Jesus' name. Now, ion. What is ion? Ion is an atom or a group of atoms. A group of atoms which possesses an electric charge. An atom or a group of atoms that possesses an electric charge is ion. Now, there are two types of ion. There are two types of ion. These are, number one, we have cation. Cation, which is positively charged ion. Positively charged ion. Then we have the anions. Anion or negatively charged ion. So examples of cations are calcium ion, potassium ion, you have ammonium ion, and so on and so forth. While examples of negatively charged ion are chloride ion, you have oxide ion, you have nitrogen ion, you have hydroxide ion, you have triazonitrate ion, you have tetraoxosulfate ion, and so on and so forth. So they carry negative charge, minus. So at their end, while cations carry positive charge, positive on their edge. So now, how are ions formed? Let's look at cations. Cations, like we said, are positively charged ions. That we have stated, e.g., potassium ion, we have aluminum ion, we have chromate ion, we have ammonium ion, and so on and so forth. Now, how are they formed? Cations are formed due to loss of electron, loss of the valence electron, the valence or outermost electron. Outermost electron or electrons of metallic atom. So when the outermost electron of the atom of a metal is lost, then it forms positive charge. And how does this happen? Let me make some explanation on that one. For example, don't forget calcium ion has a, let's say, okay, let's use magnesium. Magnesium, you have this. Magnesium has 12 protons. 6, 7, 8, okay, 9, 10, 11, 12. Then it has 12 neutrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the nucleus. This is the nucleus. Nucleus. Then you have 1, 2, 3. So we have, don't forget that magnesium is 12. Atomic number is 12. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Then you have 1, 2. So that is a 2 ratio 8 ratio 2. We have done that in the last class. This is the diagram of magnesium atom. Magnesium atom. This is atom of magnesium. So now, this is diagram of magnesium atom. This is K shell. This is L shell. This is M shell. So don't forget that the M shell now is the valence shell. Valence shell. That's the outermost shell. So the two electrons, let me bring the two of them together. The two electrons in the valence shell now, they are called valence electron. Valence electron. Valence electron. So now, this atom is electrically neutral because it has equal number of positive and negative. What do I mean? So the neutral atom of magnesium drawn above is electrically neutral. Electrically neutral. Why? As it has equal number of protons which are positive and electrons which are negative. What do I mean by that? So equal number of protons. Count the positive particles here. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then count the electrons. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So equal number of positive and negative. So and that is why when you write the symbol of magnesium atom, Mg, Mg12, you will not put anything here. No charge. It's not an ion because the positive. So it means what we have here is that you have plus 12, you still have minus 12. Will it not be 0? So the number of electrons that are negative and the positive, they cancel each other. Then it doesn't have any charge. So but when magnesium atom loses its 2 valence electron, the 2 valence electron, then to attain a stable octet configuration of neon Ne10, a noble gas, then something will happen. So then what will happen? Then we have plus 12 protons, then minus what? Minus 10 electrons. It gives us what? It gives us plus 2 charge. Plus 2 charge. So if it loses these 2 electrons, now we have something like this now. We see the number of protons still remains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the mass number still remains what? 24. But when you count everything together, you have 12 plus 12. That's 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 protons, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. That's how the mass number is 24 here. So the same thing is here also. We have 12 protons and 12 neutrons. Already have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we are 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we have, this is the nucleus now. Nucleus. So don't forget, these are protons. While these chargeless ones are neutrons. These are neutrons. So now, here, this is the proton. These are protons. This is proton. While this chargeless one is what? The neutron. Now, take note of one thing here. In the neutral atom of magnesium, we have K shell, L shell, M shell, but by the time it loses these two electrons, both the electrons and the outermost shell will no longer be there again. Then we now have 1, 2, 3, 4, 5, 6, 7, 8. So we only have K shell, and we have L shell. We no longer have M shell because the electrons on the M shell have been lost. So what I now have here, if you now count, now, how many protons we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 protons. 12 protons. So then minus, how many minus? How many negative? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons. So the atom is no longer electrically neutral. The atom is no longer electrically neutral. So because of that, you are now going to have what? Take 10 away from 12, you have what? Plus 2. So now because of that, because of this, so the symbol of magnesium ion is now written as what? Mg2 plus. Is carrying this the difference between the proton and the electron number is carrying the difference. That is what we are talking about here. That's cations. Then what about anions? Anions. We have said that anions are negative. They are negative ions. So as they carry what? As they carry negative ion, negative charge. So they are negative ion. Examples are chloride ion. You have oxide ion. You have sulfide ion. We have NO3 minus ion. We have SO3 2 minus ion. SO4 2 minus ion, and so on and so forth. So then how are they formed? Now anions are formed when a neutral atom of a non-metal gains electron to fill up its outermost shell, and then attaining a stable configuration of a noble gas. So let's look at what I'm talking about here. For example, let me discuss chloride. Let me talk about, for instance, in oxide ion. Oxide ion is what? O2 minus ion. So we have the following diagram. The following diagram of neutral atom of oxygen. So this one, what we have here is the diagram of magnesium ion. Magnesium ion, that's Mg2+. So now, alright, oxygen is number 8. You have 1, 2, 3, 4, 5, 6, 7, 8. And that's the proton number. That's proton. Proton is 8. Then neutron is also 8. 1, 2, 3, 4, 5, 6, 7, 8. Then we have the nucleus. This is the nucleus. Then we have 2 atomic shell. The first shell is the what? The K shell. While the next one is what? The L shell. The L shell now is the what? The valence or outermost shell. So that's the valence shell or the outermost shell. Now don't forget that the electronic configuration of oxygen is 2:6. So because of that, we are going to have 1, 2. Then 6 will now be 1, 2, 3, 4, 5, 6. So that is that. So this atom above is electrically neutral. So the neutral atom of oxygen is said to be what? To be electrically neutral. It is electrically neutral. Why is it electrically neutral? Because it has equal number of positive protons and negative electrons. So what are we saying? We are saying that the proton number is equal to the electron number, which is equal to what? To 8. So the proton numbers now, let's count 1, 2, 3, 4, 5, 6, 7, 8. Then the electron number 1, 2, 3, 4, 5, 6, 7, 8. So now in this place now we have what? Plus 8 minus 8 gives us 0. So this atom is said to be electrically neutral because it has equal number of protons which are positive and electrons which are negative. So then during chemical reaction, now oxide ion receives 2 electrons from a cation, from cations to fill up his outermost or valence shell. Now, and then, so with this, okay, let's see what we are talking about here. You have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So what we have here now is the diagram of oxygen atom, which is O816. So why 16? That the 16 is the mass number, which is the sum of proton number and neutron number. 1, 2, 3, 4, 5, 6, 7, 8 proton number. 9, 10, 11, 12, 13, 14, 15, 16. 8 neutron number. So add them together, you have 16. So we have this. This is the nucleus. nucleus. This is the neutron. This is the neutron. The neutron. And why this is the proton. This is the proton. All this positive charge. Then we have 1, 2. So the configuration before was 2 to 6. But now it's now going to be 2 to 8. Because it has taken 2 electrons to add to this 6. So before we used to have 1, 2. We used to have then 1, 2, 3, 4, 5, 6. Then this one we pair with one strange electron, another strange electron. So this is our K shell, while this is our L shell, which is our valence shell. Valence shell. So our K shell or our valence shell. So just take note of that. So at the end of the day, the configuration now, you now have excess electron, the strange one added before. So in this place now, we now have what? We have how many? Plus 8 protons. Minus how many electrons now? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Minus 10 electrons. Answer is going to be minus 2 charge. So the charge it will carry now. So now that we have excess of 2 gain electrons which are negatively charged, then the symbol of oxide ion, not oxygen ion now, oxide ion is O2 minus. This 2 minus is the excess, and when you subtract the 10 electrons from the 8 protons, you have minus 2. That is what is carrying as its charge. So the summary of what we are saying here is that for positive ions to be formed, the valence electron, the outermost electron, is lost to form this one, which is now 2 to what? 2 to 8. You no longer have 2 to 8 because this 2 has gone. So then when you now say the protons minus the electron, the excess of the positive is what it carries. So and in that place, that means when you want to form ion. Okay, let's look at a table of ions, then we'll get more understanding from what we are saying here. Let's come here. Now let's look at a table of ions. Now let's look at serial number. Let's look at elements, element name, then element name and symbol, atomic symbol, then electron configuration, atomic electron configuration, then ion, symbol of ion, then electron configuration of ion, Okay, let's start with number 1 is hydrogen. This atomic symbol of hydrogen is H, and the electron configuration of hydrogen has only 1 electron. It can decide to lose this 1 electron and form H+. Why? Don't forget that hydrogen, for example, hydrogen has only 1 positive and 1 electron. it has lost this one. You are not going to be left with what? Only one positive, which is carrying on its head. And that is why most of the time I want to tell you that this some question they will tell you that which of the following elements, which of the following species is often regarded as a proton. Hydrogen ion is always known as proton because hydrogen atom, neutral atom, has only two subparticles of atom, which is proton and electron. It does not have neutron number. That is why its mass number is equal to its atomic number. So by the time it now loses the only one electron it has, it's now going to fall back at proton as the only component of an atom. So hydrogen ion is often referred to as what? As protons. Take note of that. So then the configuration that is now going to be 0, it has no electron again. So that is that. Then number 2 is helium. Don't forget that I said helium is a noble gas. And noble gas, they are inert, they do not react because their outermost shell, they are fully filled. The configuration is 2. It doesn't form ion. So the 2 is occupying K shell directly. So number 3 is lithium. Lithium is Li. That's atomic number of 3. The configuration is 2 to 1. Now, when what is here is 1 or 2 or 3, the symbol of the ion is very simple. You just write Li. This is 1. When it is 1, it's supposed to carry that as plus. Don't say plus 1. When it is 1, just put plus. When it is 2, put 2, then put the plus behind the 2. So this is lithium ion, and the configuration now meaning that this plus now means that it has lost this one electron to become 2, to now look like helium. Now I told you when ions are formed, they now have electron configuration that resembles that of a noble gas. Now, so that is that. Now number 4 then is beryllium. Beryllium is Be. Configuration is 2 to 2. Now, what you have here is going to be Be2 plus. So the configuration is now also going to be 2. So it has lost 2 electrons. So don't look at it this way. Some people are confusing themselves. They will say, now, but you said a plus should be sign of addition. It should be that the atom has gained electron, not that it has lost. No. That is ordinary belief. But in chemistry, when something carries a positive charge, it means it has lost the number of the positive charge, the number of the electrons. That we have demonstrated why it is. So when you take a check between the difference between the electrons and the proton, the one that is in excess is what? Is proton. That is why we have it here. So take note of that. Then we have boron. Boron B. Configuration is 2 to 3. Then it carries it as B3 plus. And the configuration is also 2 when it has lost this 3. Then number 6 now is carbon. Don't forget now, carbon is 2 to 4. And this is K shell, this is L shell. L shell can carry maximum of 8. And half of 8 is 4. From 4 upward, they begin to form negative ion. So this one will now be C4 minus. What does this minus mean? It means that before it used to be 2 to 4, but it has now added 2 to this 4. I mean 4 to this 4, to now become 2 to 8, looking like neon. That's 8 plus 2, 10. So that's a noble gas. Then the next one, number 7, is nitrogen. Nitrogen N. So the configuration is 2 to 5. 2 to 5. So here, now when it is negative, it's not like the positive that whatever thing you see here, you raise it to the power and you put plus. No. But when the number of electrons is now 4 and above, what we need to do is write the symbol of the element. After doing that, then you remove this 5 from 8. What is your answer? Is 3. Write the 3 and put minus behind it. So it means that it has borrowed 3 to this 5, and the configuration is now going to be 2 to 8, like neon in noble gas. Then number 8, the next one is oxygen. Oxygen is O, and configuration is 2 to 6. 2 to 6. So take note of that. So in this place, then look at this. This one is now going to be O. Then what is here? Take it away from 8. You have 2. Write the 2 here and put minus. It has borrowed 2 to add to this 6. Configuration is now 2 to 8. That is that of neon. Number 9 is fluorine. Fluorine F. We have 2 to 7. 2 to 7. So because of this, now take away this 7 from 8, you have what? F minus. F minus. That's what you have there. So then the configuration is now what? 2 to 8. It has borrowed 1 to add to this 7. So that's what we have there. Number 10 is neon. Neon, Ne. 2 to 8. You know, neon is a noble gas. And noble gases do not form ions. So it doesn't form ion. So because its outermost shell is fully filled. N shell can carry maximum of 8 and you have 8 there. So that is that. 11 now, sodium. After a noble gas, we now begin with positive ion. Sodium atom is Na. Sodium atom. Then is the configuration is 2 to 8 to 1. Then when you lose this one, it becomes Na plus. Then what does it mean? The configuration is now 2 to 8. When it loses this, you no longer write it. It has lost it to carry the charge of plus 1. Then number 12 is magnesium. Magnesium Mg. Magnesium Mg. So this one has 12, that's a 2 to 8 to 2. So the ion will now become Mg, whatever you have here, 2 plus. To form positive ion is easier than to form negative ion, because whatever thing you have as the valence electron is what you put at the top, and you put plus behind it. So the configuration is now 2 to 8, like that of a noble gas. So this part is going now. This part is going now. Number 13 now is aluminium. Aluminium. And the atomic symbol is Al. Is number 13. Configuration is now going to be 2 to 8 to 3. Then it uses this 3 to form Al3 plus. And the configuration of the ion is now 2 to 8, like neon. Then the next one is 14, that's silicon. Silicon Si. This one is 2 to 8 to 4. Now, once you have 4, what you are going to have is Si. Take away this 4 from 8, you have 4. Write the 4 and put minus. So it means it has borrowed 4 to this 4. Configuration is now 2 to 8 to another 8, looking like argon, another noble gas. Number 15 is phosphorus. Phosphorus P. Configuration is 2 to 8 to 5. So this one now, you are going to have P what? Take this 5 away from 8, you have what? 3. Then put minus behind it. Then the configuration is now 2 to 8 to another 8, because 3 has been added to this 5. You have that. So then the next one, number 16, is sulfur. Sulfur S. Then the configuration is what? Is 2 to 8 to 6. So sulfur S, then take this 6 away from 8. You have 6 away from 8 is what? Is 2. Put the 2 here and put minus. Configuration is now 2 to 8 to another 8. That is argon, looking like argon. Number 17 now is chlorine. Chlorine Cl. Configuration is 2 to 8 to 7. So then the symbol of the ion is Cl raised to power minus. How did I get that? Take this 7 away from 8, you have 1. But when it is 1, you don't need to write the 1, just write the sign, minus. So the configuration is now 2 to 8 to another 8. Then number 18 now is argon, which is a noble gas. Argon Ar is a noble gas. So noble gas do not react. Configuration is 2 to 8 to another 8. It doesn't form ion because it's a noble gas, they are not reactive. Number 19 is potassium. Potassium K. So configuration is 2 to 8 to another 8. So to another 8 to 1. So then whatever thing is here, this one, just put it as the head. This potassium ion configuration is now 2 to 8 to another 8. This one has vanished. It has lost it. Then number 20 is calcium. Calcium, Ca. Configuration is 2 to 8 to another 8 to 2. So this, the ion is going to be Ca2 plus. It has lost these 2 to now form 2 to 8 to 8. No more 2 is here. So that is what we have there. Now, so with that that we have here, so that is the ions for the first 20 elements. Let's now talk about radicals. Radicals. Don't forget, when we're talking about ions, I told you that an ion is an atom or a group of atoms. So we have just concluded in the first part now, ions as atoms that carry common charge. Now radicals now, a group of atoms that carries a common charge. So a radical is a group of atoms of different elements which carries a common charge, a common electric charge, and behave as a single entity. Behaves as a single entity or as a single unit. So now let's look at examples of radicals. Serial number. I have IUPAC name. Or before that, let me look at symbol of radical. Then we have IUPAC name. Let me just deal with the IUPAC name. The first one I want to talk about is OH minus. OH minus is hydroxide ion. Hydroxide ion. Please, you have to memorize these names. Hydroxide ion. When you see O and H, then they carry a common charge, a group of atoms of different elements of oxygen and hydrogen, carrying this minus one now, and these two now they are behaving as if they are just only one thing like boron. So number two is you have ammonium ion, that's Na4 plus, which is ammonium ion. Ammonium ion. So that is that. Then number 3, we have SO4 2 minus ion. Now, if you want to call this one, this is 4. And when you have 4 tetra, when you have 1 mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hecta, 8 octa, 9 nona, 10 deca. This is 4. This 4 means what? Tetra. This oxygen means oxo. This sulfur means sulfate. But you will now put Roman figure Vi. This is ion. This is tetra also sulfate 6 ion. The question is, uncle, where did we get this Vi? This 6. Now, don't forget that sulfur is what? Where is it? Number 16. You see here, that's 2 to 8 to 6. Because of this 6, what type of sulfur is it? The sulfur that the oxidation number is 6 is Vi. So that's what I represented with that. So, but it is not in all cases that it is like that. But in most of the cases, to make the work very simple for you, that is that. Now, so let's look at other ones. Number 4 now. Number 4, you can have HSO4 minus. Look at this one. This is SO4 2 minus. We can decide to put H before we put the SO4. But by the time we do that, the 2 minus will change to ordinary minus. So, and the IUPAC becomes, you mention this one first, hydrogen, then this one is what? Tetra, then this oxygen is what? Oxo, this sulfur is what? Sulfate, tetrasulfate 6, it's still the same thing as sulfate 6. So then number 5, we can have SO3 2 minus. Now this one is what? This thing is what? Tri. This oxygen is what? Oxo. This sulfur is what? Sulfate. But this time around, it's going to be 4 iron. That is trisulfate 4 iron. You can no longer use this thing. You just have to memorize this one. That's why I told you it's not enough cases that we have it like that. You can also introduce hydrogen here before we have the SO3. But this time around, instead of writing 2 minus, it now becomes 1. Then this is what? Hydrogen. Then you come back. Trioxosulfate 4 iron. So that's what we have there. So number 7, you can have NO3 minus. So this one is this is tri, this oxygen is oxo, this nitrogen is nitrate, triazonitrate 5 iron. How did I get the 5? Nitrogen is number 7. Check here. That's 2:5 because it ends in 5. Then I put the 5. What type of nitrogen? This is triazonitrate. What type of nitrate? The one that the valence electron is what? Is 5. So that is that. Then the next one, number 8, let's look at NO2 minus. When it is 2, that is di. This oxygen is what? Oxo. This nitrogen is what? Nitrate. But this time around is what? III. So when this is 3, but you can no longer use that 2:8. You can use this, but this one did not end with 3. But you can still say that the ion, it gains 3 more electrons to this one from 2 to 8. So that 3 might be what they mean here. So then number 9, we have CO3 2 minus. This is a trioxo. This carbon is carbonate 4 ion. Yes, carbon is number 6. That is 2:4. It ends in 4. Because of that, that's why we have this IV. Then we can also have number 10. We are going to 17. So we can introduce hydrogen here before we write the CO3. But this time around, instead of writing 2 minus, we write just only 1 minus. So for this one, that become what? Hydrogen, then come here, triazocarbonate 4 ion. So that's what we have there. Number 11. So we can also have something like this. We can have S2O3 2 minus. Now this is what? Trioxo. When sulfur has 2 under, it becomes thiosulfate 6 ion. So take note of that. Then the next one, number 12, we have MnO4 minus. This one is tetra, that's 4. This oxygen is oxo. This Mn is manganate. Tetra ozomanganate what? 7 ion. So that is that. That 7, just have to memorize it. There is nothing to prove it out. Then number 13 is Cr2O7 2 minus. 7 is what? Hepta. Oxygen is what? Oxo. This 2 is what? Di. This here is what? Chromate. Then we have what? Vi ion. So what we have here is heptaoxo dichromate 6 ion. So that is what we have. Number 14. We can also have ClO3 minus. This one now is going to be what? This 3 is what? This oxygen is what? Oxo. This chlorine is what? Chlorate. Triazochlorate 5 ion. So that's what we have there. Triazochlorate 5 ion. Then number 15. So please, you have to master the names and then the symbol of this. It's very, very important. You have to sit down by yourself and memorize them. Then this oxygen can come behind. Or we can see have something like this. ClO4 minus. Then this one is going to be what? Tetraoxochlorate 7 ion. Tetraoxochlorate 7 ion. Please, you have to memorize it like that. So let's go on. Now, is you can decide to have the OCl minus. The oxygen is behind. This one is oxochlorate 1 ion. Oxochlorate 1 ion. It can also be OBr minus. So this is oxobromate 1 ion. Please take note of that. So that is that. Then we can also have 18. We can also have PO4 3 minus. This 4 is what? Tetra. This oxygen is what? Oxo. This phosphorus is what? Phosphate. Tetra also phosphate. Tetra also phosphate. 5 ion. Why 5? Because phosphorus is number 15 and configuration is 2 to 8 to 5. This 5 is what we have here. Please take note of that. Then the next one, number 19, is PO3 3 minus. This oxygen, this 3 is what? Tri. This oxygen is oxo. This is phosphate. Tri also phosphate. This time around 3 ion. How did we get the 3 ion? If phosphorus now borrows 3 to add to this 5, it becomes 2 to 8 to 8. So that 3 borrows is what we have here. So we have come to the end of ions and radicals. That is the end of ions and radicals. So then we can move on to look at valency and oxidation state. Valency and oxidation state. Valency. What is valency? Valency. Valency. Valency is the combining power. Combining power. The combining power of a species. That species can be an atom, can be radical, whatever. So why oxidation number? Why oxidation number? Oxidation number. Oxidation number is the electric charge. Electric charge of an ion or a molecule. Electric charge that something carries. So let's look at example of species. Species. The ion or the species. The ion, ion and symbol of ion. Symbol of ion of the species. Then we have the valency. Let's start with oxidation number, or you call it oxidation state. Then we have valency. Valency. If somebody talks of chlorine, what type of ion does chlorine forms? Chlorine 17, that's Cl minus. So this, because of this minus, the oxidation number is minus 1. Why the valency is 1 without the charge? That's the combining power. Number 2, let me just take it randomly. Magnesium. Magnesium is Mg. Chlorine is Cl. Magnesium Mg. What type of ion does magnesium form? Mg2+. Can see that number 12, Mg2+, still on the board, Mg2+. So because of that, its oxidation number is what? Plus, to return this plus to the front of these 2. And the valency is what? Is 2. Now, and okay, I'm still coming to talk about that. Now, number 3, you can have tetraoxosulfate 6 ion. That's SO4 2 minus ion. The oxidation number is what? Is minus 2. While the valency is what? Is 2. So what do I want to say here? I want to say something here, very important. I want to say something in this place. Now, this is valency, please. Now, a species with only one valency is called a monovalent monovalent species, e.g. A plus, Na plus, and so on and so ahead. Not only that, Cl minus, then F minus. So those ones that have plus 1 or minus 1 on their head, when they form ions, they are monovalent. So a species, let me put radical now. Radical like Na4 plus, radical like OH minus, etc. So they are monovalent. Then a species with 2 valency is a divalent species. E.g., let's look at Mg2 plus. Let's look at SO4 2 minus, O2 minus. They carry 2 2. So and so on and so forth. They are divalent, whether positive or negative. So a species with 4 valency, 3 valency is a trivalent species. E.g., aluminium ion Al3 plus, then PO3 3 minus, PO4 3 minus, Cl3 plus, and so on and so forth. Then we have ion Fe3 plus, and so on and so forth. All these are trivalent. Now take notes. Then another thing I want to tell you here is that the valency, the oxidation number of a radical is the sum of the oxidation number of its combining atoms. What do I mean by that? So what do I mean by that? Let me show you what I'm talking about here. Now, what do I mean by what I've just said? If, for instance, let's look at in SO4 2 minus. This one now contains, so this radical contains, we have sulfate 6 ion, which is S6 plus. So in some exceptional case, it is possible. This is not the only type of ion sulfur can form. This one is the commonest one, 2 minus. When you add 6, 2 to the 6. There are some exceptional cases where you can lose the whole of the 6 and carry it as well, sulfate 6 ion. That's when it is S, this one. So it contains this one. And oxide ion and 4 atoms or 4 units of what? Of oxide ion. So I say 4 times O2 minus 4 oxide ion combines with this. So let's look at the arithmetic now. The arithmetic now carry the charge of this. That's plus 6. Return is equal to the back. We are adding it down to what? Oxygen is what? Oxygen is minus 2, but in this formula we have 4 of them times 4. So we have plus 6 plus into minus 2 times 4 is minus 8. So we have plus 6 plus times minus is minus 8. Then 6 plus 6 minus 8 is what? Is minus 2. So this minus 2, these 2 minus that SO4 2 minus ion is carrying is, that's why the two of them have operated together to have that. Let's look at what about in trioxocarbonate 4 ion, that is CO3 2 minus. Now we have carbonate 4 ion. We have carbonate 4 ion. which is C4 plus. You know, carbon can also, carbon is 2 to 4. It can decide to lose this 4 and form C4 plus. It can also form C4 minus. So here now is this. And we have what? 3 units of what? Of oxide ion combining together. So now we now have what? So that is 3 times minus 2. 3 times of what? Of oxide ion combining. So at the end of the day, we have 4 plus into minus 2 for oxygen times 3. So we have 4 plus into minus 6. So minus 2 times 3. So we have 4 plus times minus is minus 6. Answer is what? Minus 2. So that is why, so you can now see, so that is that. So take note of that. So you are going to learn more of this one we have talked about when we get to some topics in SS2 under redox reaction. So under redox reaction, that's when we are going to talk about that. So in the next class, we are going to look at some why questions that speak on ions. So we are going to talk about them before we move on. So see you in the next class. I remain Ademola Johnson. If what I have done is beneficial to you, do click the subscribe button, and do what? Click the notification button and share this video. And share. God bless you in Jesus' name. Thank you. God bless you. Bye for now.